So, good evening, all of you. So, again, I welcome you in this practice session of PGT Physics exam. Especially, this I have taken for according to KVS examination, and we were discussing the chapter of electrostatic potential. So, as you know that in this practice session, we just only summarize the important concepts and then we practice questions. So if you have received this file, we have summarized up to electrostatic energy. Electrostatic energy we have summarized. Now, then we have properties of conductors, and then what will happen when a dielectric is placed in an external magnetic field. And then based on this, we have capacitors, especially parallel plate capacitor. So we will take example based on these particular topics. So now we will see. Just give me 1 minute. So you know the properties of conductors. We have to take questions. Properties of conductors. So what are the property? You know, E is 0 inside conductor. Electric field is always 0 inside conductor. Charge density rho is also 0 inside conductor. Potential is constant. Potential is constant inside. Potential remains constant because electric field is 0. Any net charge resides on the surface only. And what will be electric field due to conductor? E is perpendicular to the surface just outside the conductor, just outside the conductor. And you know that this electric field will be given by C by epsilon, sigma by epsilon naught n cap, where sigma is surface charge density. So if you know the surface charge density on the surface of the conductor, you know the electric field. If charge is positive, this surface charge is positive, field will be outward. If charge density is negative, this direction will be towards the surface. So this is the electric field due to conductor. Clear? So we have to take some example based on properties of conductors. Just see this, that is summarized in part point number 8. This is the properties of conductor. And then you know that if you have a conductor, if this is a conductor, let's say it's a conductor. If this conductor is placed in some external field, what will happen? Because there are in a conducting material, there are regular arrangements of atoms, but one or two electrons are free from their particular atom. So they are free to move. So there will be free electrons in a conductor. And when this is placed in an external field, what will happen? This free electron will shift towards this side, and this positive nucleus will shift towards this side. As a result, there will be a development of electric field opposite to the external field. So charge accumulation will keep on increasing until E is equal to E naught. So you will see when E is equal to E naught inside the conductor, resultant field will be 0. So that is the case of conductor. But if this metal is not conductor, if this is dielectric, then what will happen? So instead of conductor, if this metal is dielectric, let's say it's a dielectric material. So what is dielectric material? Again, there are regular arrangements of atoms, but in this case, electrons are tightly attached with their nucleus. They are not free to move. So if you are considering, these are the regular arrangements of atoms and electrons are tightly attached. So when this is placed in an external field, again what will happen? Each atom will get polarized. What do you mean by each atom will get polarized? For example, let's say in an atom you have a nucleus and it is surrounded by a electron cloud, and I am assuming it has a spherical shape. When this atom is placed in an external field, what will happen? This external field will try to push the nucleus towards right, electron cloud towards left. This electric field will push the nucleus towards right, electron cloud towards left. And so what will happen? Then there will be a attraction between these positive and negative charges. And you will see a equilibrium will exist. So between the forces that tries to separate these two charges and their attraction between positive and negative charges. And when equilibrium will establish, you will see nucleus will be shift toward this side and electron cloud will shift towards this side. So this is like a small dipole. And we say that this atom get polarized. This is the polarized atom. This is the polarized atom. So one single atom, when electrons are tightly attached with their nucleus, when that is placed in an external field, it gets polarized. And we can define its dipole moment as P is Q into D. Now, in a dielectric material, there are regular arrangements of these atoms. So each atom will get polarized. So what will happen? There will be minus, plus, minus, plus. Each atom gets polarized. Each atom gets polarized. And if so, we say that this material gets polarized. In a material gets polarized. And if you are assuming if you are assuming that this polarization is uniform, then internally these charges will cancel out. Then internally these charges will cancel out. And on this surface, positive charge develop, and on this surface, negative charge will develop. So these charges are called as bound charges. These charges are called as bound charges. So in case of dielectric, again electric field will develop inside opposite to E, but that will not cancel the external field. In case of conductor, this field exactly cancels the external field. So electric field is always zero. But when you have a dielectric, this electric field doesn't cancels exactly. So field will be non-zero. Field will be non-zero. So when you have a dielectric material, it gets polarized. There will be bound charge. On the surface, you have surface bound charge. Inside, you have volume bound charge. So that is how you have to distinguish between a conductor and a dielectric and their behavior in an external field. Clear? Now, question will be asked based on the parallel plate capacitors. So let's see summary of parallel plate capacitor. You know about parallel plate capacitor. So in a capacitor, parallel plate capacitor, parallel plate capacitor. So we have to consider two large parallel plates. These are two large parallel plates, and this contains charge plus Q. They are connected with a battery, and this with connects this contains charge minus Q, and their separation is D, and plate area is A. So, and when it is connected with some supply voltage, let's say V, then you will see Q by V is a constant value, and that constant defines its capacitance. Q by V is a constant value. D is the separation between these two plates. This is area of the plate and plate area, and we are also considering that the D square is far less than A. So capacitance of this particular arrangement is Q by V, and it's a pure geometrical quantity. And for parallel plate capacitor, this value is given by epsilon naught A by D. I'm just giving you the result that you have to remember. So question may be asked based on the capacitance, and unit of the capacitance is farad. Epsilon naught is permittivity of free space. But when it's a dielectric field, if this parallel plate capacitor, there is a dielectric field. If you have inserted a dielectric material here, having dielectric constant K, K is the dielectric constant. And let's write this as C naught in free space. When there is a free space in between, capacitance is C naught. But when it is a dielectric field having K as a dielectric constant, K as a dielectric constant, then capacitance C will be C naught by K. Capacitance will be K times, means capacitance will increase. And if you will see, electric field in free space cases, let's say sigma by epsilon naught, and if potential is V naught, potential difference is V naught. So in dielectric field case, electric field is given by E naught by K, and also potential is given by V naught by K. Means capacitance will increase, electric field between plates will decrease, and also potential difference will decrease. Clear? So we will see some question based on this particular result, parallel plate capacitor. Then you have series and parallel combination. You know, when capacitors are in series combination, so in series combination, charge on each plate will be same. And in that case, capacitance, equivalent capacitance is 1 by C is 1 by C1 plus 1 by C2 if there are n number of capacitors. If they are in parallel voltages will be same. When capacitors are connected in parallel, voltages will be same. And when they are connected in series, charge will be same on each capacitor. So this is series combination, parallel combination, and then there will be energy stored in a capacitor of capacitance C. So that energy stored is given by half QV, because Q is CV. So that can be written as half CV square or Q square by 2C also. This is the energy stored in the capacitor. And if you have to write the energy density, energy per unit volume is stored in the field, that is half epsilon naught E square. So that is the summary for this chapter. Now we will see questions based on this. So we have already discussed some questions. Now let's see. Let's start with question number 12. Let's see question number 14. See question number 14. You have a spherical conductor of radius 12 meter, 12 centimeter, and has a charge 1.6. Let's see. Try to solve it. A spherical conductor of radius 12 centimeter has a charge of 1.6 10 to the power minus 7 coulomb distributed uniformly on its surface. What is the electric field inside the sphere, just outside the sphere, and at a point 18 centimeter from the center of the sphere? Just check this value. So you can, so let's see question number 14. A spherical conductor of radius 12 centimeter. This radius is 12 centimeter. And it contains charge distributed over it is 1.6 10 to power minus 7 coulomb. What is the electric field inside? So inside means when you have a some point R less than 12 centimeter, electric field will be zero because it's a conductor. Clear? Electric field inside the conductor will be zero. And what will be the electric field just outside the sphere? So at R is equal to 12 centimeter. So this electric field is given by Q by 4 pi epsilon naught R square. So this is 1.6 10 to power minus 7 9 into 10 to power 9 divided by 0.12 whole square. So it's a conductor. So you have to assume that all charges are concentrated here. So r distance away, this is the formula, just like a point charge. And this value is 10 to power 5 Newton per coulomb. And in same way, you should find when r is equal to 18 centimeter. Same formula. So this value will be 9 into 10 to power 9, 1.6 10 to power minus 7 divided by 18 into 10 to power minus 2 whole square. And this value is 4.4 10 to power 4 Newton per coulomb. Clear? So it's a direct question, but it's a conductor. Inside electric field will be zero. Now, a parallel plate capacitor with air between the plate has a capacitance of 8 picofarad. What will be the capacitance if the distance between the plate is reduced by half and the space between them is filled with a substance of dielectric constant 6? So let's see. It's a matter of calculation only. So question number 15. So parallel plate with air between the plate has a capacitance C naught is 8 picofarad. And this will be 8 into 10 to power. What will be the value? So let's calculate in picofarad itself. So what will be the capacitance if the distance between the plates is reduced by half? So C naught is epsilon naught A by D. So this will be given by, and the K times of epsilon naught A D by 2. So this will be K value is 6. So you will get twice K epsilon naught A by D. So that is twice K C naught. So 2 into 6, C naught is 8 picofarad. So this will be 96 picofarad. ठीक है. Now you have question number 16. Let's see. Question number 16. The capacitors, each of the capacitance 9 picofarad are connected in series. So they are correct. What is the total capacitance? So in series, it is given by 1 by C dash is 1 by C1 plus 1 by C2 plus 1 by C3. So this will be 1 by 9 plus 1 by 9, 3 by 9. So C dash is 3 picofarad. It will be 3 picofarad. Now, what is the potential difference across each capacitor if combination is connected to 120 volt supply? So because they are in series, so they have equal capacitance, so drop will be same, 40 volt each. So in this case, you will get drop V dash will be V by 3. So that will be 40 volt each. So these are the direct questions. In same way, you can find if you have a 3 capacitors, they are connected in parallel. What is the total capacitance? Determine the charge on each capacitor if connected to a 100 volt supply. So let's see what will be charge on each capacitor. These are the simple question, but question number 17. So what will be the capacitance? Parallel is C1 plus C2 plus C3. So this will be 2 picofarad plus 3 picofarad plus 4 picofarad. 9 picofarad. This will be the total capacitance. A part. And in B part, voltage is V is 100 volts. So in parallel, voltages are same. So what will be charge on each capacitor? So Q1 will be C1 into V because potential is same. So C1 is 2 picofarad. So 2 into 10 to power minus 12 farad into 100. So this will give you what? 2 into 10 to power minus 10 coulomb. So this will be charge on one capacitor. Similarly, Q2 is C2 into V. C2 is 3. So this will give you 3 into 10 to power minus 10 coulomb. And similarly, Q3 is V is 100. And then this will give you 4 into 10 to power minus 10 coulomb. So these are the direct question you can easily solve. Now see question number 19 or question number 18. Let's solve question number 18. Yes. Try to solve it. A slab of material of dielectric constant K has the same area as that of the plate, parallel plate capacitor, but has a thickness of 3 by 4D, where D is the separation of the plates. How is the capacitance changed when the slab is inserted between the plates? So now this is the parallel plate capacitor. This separation is D. Now you have inserted a dielectric having 3 by 4D. Let's consider this. This will be 3 by 4D. 3 by 4D. So how capacitance will change? So initially, now what will be the new potential difference? So potential difference between these 2 points is V, and V is given by E1 into D1 plus E2 into D2. You have to see when this dielectric is inserted, what will be potential difference? So electric field is V by D. So potential difference is, because you have, this is free space, this is dielectric. So E1 is electric field in this region. Here you have E1, and I am taking this distance to be D1, and this electric field is E2. So you know that in free space, electric field is given by what? Let's say this field is E naught. E naught into D, D by 4. D1 is D by 4 and electric field is E naught. E2 electric field will be E naught by K, and D2 is 3 by 4D. And E naught is V naught by D. E naught is V naught by D. So this is V naught by D into D by 4 plus V naught by dk into 3 by 4 d. So this d will cancel out and you can take V naught common. So this is k plus 3 by 4k. So in this case, potential decreases by 4k by k plus 3. But charge on the capacitor remains same. So what will be C? C will be given by Q naught by V. So this will give you Q naught by V naught, and then this is V naught by so Q by V. So this is V naught by 4k. This value is what? So V naught by V. So this will be given by V naught k plus 3 by 4k. Q naught V naught is C naught, and this will be 4k by k plus 3. So it will increase by 4k by k plus 3. So this is the new capacitance. If you insert a dielectric of thickness 3 by 4d and its dielectric constant is k. Now you should find question number 19. Try to solve question number 19. So question number 19, let's see, a network of 4 10 microfarad capacitors is connected to a 500-volt supply. First part, determine the equivalent capacitance of the network. So what will be equivalent capacitance? Just see which are in series and which are in parallel. So when they are in series, they have same charge, and charge will be, let's say, in if you're connected in series, so this charge will be plus minus plus minus plus minus. So these three capacitors are in series, and then that will be in parallel with C4. So what will be the equivalent capacitance of C1, C2 and C3, because they are in series? So I will write 1 by C dash will be given by C1 plus C2 plus C3. And this will be, they are of 10 microfarad. So this is 3 by 10. And so C dash is 10 by 3 microfarad. This is the equivalent capacitance of C1, C2 and C3. Now this is in parallel with C4. So this will be C dash plus C4, and that will be 10 by 3 plus 10. So this is 40 by 3 microfarad. This is the equivalent capacitance, A part. Now B part, the charge on each capacitor. What will be charge on each capacitor? So in parallel, potential will be same. So along these three, total potential difference will be 500. So on one particular, you should divide it by 500 by 3. So in B part, what is the potential difference across? First, this is Q by C1. This is the potential difference, plus Q by C2 plus Q by C3, and this will be 500 volt. And Q dash by C4 is also 500 volt. So what will be charge Q? This will give you, from here you will get Q by C dash is 500, or Q is equal to 500 into C dash. C dash is 10 by 3 into, this will be 10 by 3 microcoulomb. 10 by 3 microcoulomb. So if you calculate this value, this is 5000 by 3 into 10 to power minus 6 coulombs. So that will be 1.33 into 10 to power minus 3 coulomb. So this will be charge on C1, C2 and C3. And from here you will get charge on Q4. So 500 into 10 into 10 to power minus 6 coulomb. So this is 5 into 10 to power minus 3 coulombs. ठीक है. So in this way you can find the charge on the each capacitor. Clear? Now see question number 20. Try to solve question number 20. Solve question number 20. Solve question number 20. A 900 picofarad capacitor, this is given, is charged by a 100-volt battery. How much electrostatic energy is stored by the capacitor? So what is the electrostatic energy stored in the capacitor? This is given by energy stored is energy stored in the capacitor is half CV square. C is given 900 picofarad. So half 900 into 10 to power minus 12, and V is what? 100-volt whole square. So this is 10 to power 4. So 1 by 2, 900 into 10 to power minus 8. And this will be, this you can write 4.5 into 10 to power minus 6 joules. So this is the energy stored. In part A. Now in part B, the capacitor is disconnected. Now it is charged up to 100-volt. The capacitor is disconnected from the battery and connected to another 900 picofarad capacitor. So what will be the electrostatic energy stored by the system? So because they are of equal capacitance, so what will happen? This charge will distribute equally on both capacitor. So in a new arrangement, so what will be the total charge? Total charge Q dash will be given by charge on each will be given by Q CV dash. And because total charge is fixed, so there this Q dash is Q by 2. So this will give you V dash is V by 2. From the charge conservation, you will get Q dash is Q by 2. So Q by 2 plus Q by 2, total charge will be Q. So potential will be V dash by 2. So what is the total energy of the system? Total energy of the system, this will be given by, now you have two capacitors and they have charge Q dash, potential is V dash. So this will be Q dash is Q by 2 and V dash is V by 2. So this is 1 by 4 Q into V. And that value is 1 by 4 and Q is equal to CV. So 1 by 4 CV square, where I have taken Q is equal to C into V. And if then you have to take 1 by 2 of this value. So this is 2.25 10 to power minus 6 joules. Okay? So that is question based on energy stored in parallel plate capacitor. Now question number 21. Try to solve question number 21. Question number 21. A 600 picofarad capacitor is charged by a 200 volt supply. It is then disconnected from the supply and is connected to another uncharged 600 picofarad capacitor. How much energy, electrostatic energy is lost in this process? So you have a similar question like this. So question number 21. Is, so energy stored will be given by half of CV square. So this is half 600 into 10 to power minus 12 and V is 200 whole square. And if you calculate this value, this is 1.2 into 10 to power minus 5 joules. This will be the energy. If it is connected together with another 600 picofarad capacitor, so it is then disconnected from the supply and is connected to another uncharged 600 picofarad capacitor. So what will be the equivalent capacitance? So when you connect with another charge, so that equivalent capacitance is given by 1 by C plus 1 by C, and this will be 2 by C. So C dash is C by 2. So this is 300 picofarad capacitor. And now the new electrostatic energy is given by this will be again half C dash into V square. So this is half because I have taken capacitance. So total voltage drop will be 200. So this is 300 into 10 to power minus 12 and then 200 volt whole square. So this value is, let's calculate this value. I think this is 0.6 into 10 to power minus 5 joules. So how much energy is lost? So loss in energy is given by E minus E dash. So this will be 1.2 minus 0.6. So this will be 0.6 into 10 to power minus 5 joules. this much energy will be lost. In this process, energy lost will be 0.6 into 10 to power minus 5 joules. Clear? So we have taken examples based on parallel plate capacitor, and we have also discussed the properties of conductors. Now there are two questions based on, one is spherical capacitor, another is cylindrical capacitor. So I am giving you the formula for spherical and cylindrical capacitor, and you have to just calculate that value. So let's see what will be the formula for spherical capacitor and cylindrical capacitor. So you have in case of a spherical capacitor, if you have a spherical capacitor, so its inner sphere, inner radius is, let's see, its inner radius is R2 and outer radius is R1, and its capacitance in between, let's say there is a dielectric constant of K. So its capacitance is given by 4 pi epsilon naught K R1 R2 by R1 minus R2. So you have to remember this formula. What is the capacitance of a spherical capacitor? So just see, inner and outer radius is given. The outer sphere is earthed and the inner sphere is given a charge 2.5 microcoulomb. They determine the capacitance of the capacitor. What is the potential of the inner sphere? And then you have to find compare the capacitance of this capacitor with that of an isolated sphere of radius 12 centimeter. So you have to try this question, and we have another is cylindrical capacitor. So in case of cylindrical capacitor, which formula you will use? Cylindrical capacitor. So length of the cylinder is L. Let's see. Its length is L. And I am taking this outer radius is R1 and inner radius is R2. Its length is L. So in this case, capacitance C is given by 2 pi epsilon naught L ln R1 by R2. So you have to use these two results, and then you have to solve question number 22 and 23. So that will complete the second chapter. Now in next session, we will talk about third chapter, that is current electricity. So we will take summary of current electricity, and then we will discuss some question based on other topics that is related with the current and electricity. Clear? So try to solve all these questions, because in PGT exams, normally if you remember the formula and basic concepts, you can easily solve. They will not ask you difficult question. Straightforward question they will ask you. So that's why I have taken only those type of examples. I'm not going in difficult problem, because question will be straightforward. Okay. So meet you tomorrow. Thank you.